Now, in order to show you how we work with conditional probability in tree diagrams, I've given an example of a typical question that you could find in any exam. Susan goes to work then by one of two routes, A or B, and the probability of going by route A is 30%, and if she goes by route A, the probability of her being late for school is 5%. And if she goes by route B, the probability of being late is 10%. And what you've got to do is draw a tree diagram to illustrate these probabilities first of all. Okay, so I've divided this up into two sections, two trials as we call it, okay? And the first trial is about which route that Susan takes to go by school, and the second trial will be about whether she's late or not. Okay, so we're going to give some labels to each of these trials. So the first one then I'm going to say is the route that she takes. Okay, that's the route. And the second trial is about whether she's late or not. So basically it's about her lateness. Now, in the first case, she's got two options. She can either take route A or route B. So the probability that she takes route A, we're told, is 30%. Okay, so that would be, as a decimal, 0.30. Obviously, the remaining route, B, the probability she takes route B, we know that this must add up to 100% or one whole one, so that leaves us with 70%, or as a decimal, 0.70. Now, if she takes route A, the probability that she's late for school is 5%. And if she takes route B, the probability that she's late for school is 10%. Now, what you don't want to do is write the probability that she's late here is 5% or 0.05, and the probability of being late here as 0.10, 10%. What happens is that you contradict what you've written here. Okay, PL is 0.05. No, it's not. It's 0.10. This is not good enough for this type of question. So what have we got to do? Well, the probabilities of being late are dependent on the route that she takes. So we should be writing the probability of being late given that she took route A. That is 5%. That is 0.05 as a decimal. So the probability of not being late, that's L with a little dash, okay, given that she took route A, knowing that this has got to come to one whole one, must be 0.95. And similarly, the probability that she's late, given that she took route B, okay, is 10%, so that's 0.10. And so that means that the remaining branch here, because it's got to add up to 1, must be the probability that she's late, not late I mean, given that she took route B, must be 0.9, or I'll call it 90. Okay, 0.90. Okay, we've got that far, and hopefully we've got a correctly labelled tree diagram. No contradictions at all in our notation. Now the first question asks us to find the probability that Susan is late for school. So in other words, for part 1, we've got to find the probability that she is late for school. That's just simply PL. And remember that if we had written PL here as equaling 0.05 or PL down here as being 0.10, this would have caused a lot of confusion. So we'll just remove that again then. Okay. Probability of being late. How could she be late for school? Well, she could have taken route A and been late, or she could have taken route B and been late. So we could write this as the probability that she takes route A and was late. Okay. Now there's a totally different way she could be late. So this is a mutually exclusive event, so we put plus, often referred to as the or statement, okay, probability that she took A and was late, or she could have taken now route B and been late. So if we're working this out, the probability of taking route A and being late would have been 0.30 multiplied by 0.05. So I just put that in there, 0.30 times 0.05. And then plus probability of B and being late, it'll be down here and up here. So 0.70 multiplied by 0.10. 0.70 multiplied by 0.10. And if you do this on a calculator, what you get is 0.085. Or if you did it in, say, fraction mode, you would have got the fraction 17/200. Alright, so either of those two answers. Now part 2 is the more challenging part for quite a lot of people, and it is, given that Susan is late for school, find the probability that she went via route A. So in probability notation, okay, what's the probability that she took route A given that we know that she was late? Okay? And you'll see that this is not written anywhere on this tree diagram, so our notation is correct. Now what does this equal? Well, earlier on I showed you in the earlier videos that the probability of one event given another is the probability that both events occur, that is A and L. A and L. And it's always divided by the probability of the given event, and in this case it is L. So it's divided by the probability of L. Now because we stuck to the correct notation, the probability of L, there'll be no contradictions, okay, it would just be this value up here. Probability of A and L we worked out earlier on. It's 0.30 times 0.05 coming up through here. So all we've got to do then is just simply fill this in as 0.30 multiplied by 0.05, okay, probability of A and the probability of being late given that you took A, that's that probability there. All divided then by the probability of being late, and that was this value here, 0.085. And if you work this out on a calculator, you get the exact fraction 3/17, or as an approximate decimal you get 0.1764 and so on, which you might like to give to, say, 3 decimal places, which would be 0.176 to 3 dp. Okay, so hopefully you can see how we handle problems on conditional probability. And it is so important to label your tree diagram correctly, otherwise you just get contradictions in what you are saying, and it just can lead to errors.